Okay, so today we're going to finish up the visitor design pattern, which we are building on top of the composite pattern and the state design pattern with a list. One of the features of one of the characteristics of the visitor design pattern is that what used to be parameters and also what used to be values that were returned by non-void functions, those all become attributes of the visitor. So, and let me just start off by saying this. What we're going to learn today is how to translate from a non-visitor scenario to a visitor scenario. And that's the only thing I expect you to be able to do with this. And furthermore, on the next exam, it'll be this way also. In other words, I will give you the corresponding solution or the algorithm for the non-visitor setup. In other words, like for list CS, and all you have to do is translate into the visitor pattern. And that's all I'm asking you to do for the homework also. So, and that's why I was really careful to get your homeworks back with the solutions in case you didn't get them. Okay, so if you need the solutions for the list CS, let me know. I'll give you the solutions to the ones that you need in order to translate to the visitor. Is everybody with me on this? Now, really, basically, what it all boils down to is it's just a recipe. So as we go through this today, just as we go through these examples, just think, okay, this is if it's done this way over here, and if it's done this way with composite state, then it's just a recipe for doing it with the composite state visitor. So you see what I mean? So we're really not asking you to come up with new algorithms, because we've already dealt with these methods for a linked list using the composite state pattern. So now we're just going to do the plug-in version of what we've done before. Do you see what I mean? So, and that's the only thing, and I will give you on the next exam when you do, because the visitor is obviously going to be on the next exam. But what I'll do is I'll give you the corresponding composite state solution, and you just have to translate. So just as we're going through this, just think about, well, this is how I would translate. And also for your homework that's due tonight, that was postponed until being due for tomorrow, right? 24 hours. Okay, so here's the signature mechanism. What happens is a plugin is a subclass of an abstract visitor. And so therefore it's free to add any number of attributes of any type that are not present in the superclass. And so what happens is the attributes in a visitor correspond to the parameters in a non-plugin method. I should probably also have said on this slide, correspond to the parameters and any returned value. Okay, so you might want to augment that. And so here again, these are the visitor translation techniques. Now, in a regular method, we have call by reference and call by value. Are you with me? We have call by reference and call by value. So we have to translate those two scenarios in two different ways. So input parameters in the native method are attributes in the visitor initialized in the constructor. Now, I don't think we mentioned this last time, but how do you set the attributes of an object? Well, when that object is instantiated, the constructor sets it. Do you see? So if these parameters are going to if the parameters in the non-visitor method is going to correspond to the attributes in the visitor with the visitor scheme, then the way those attributes get those values is when the constructor is called. But when is the constructor called? That's when the user instantiates the user's visitor. So you see, the user knows the user would know what parameters to give to the method. Well, the user just gives those parameters to the constructor, and that's how those attributes get set. Do you see? So the input parameters in the native method are attributes in the visitor initialized in the constructor for the visitor. And furthermore, what we mean by an output parameter is like a call by reference, because when a function changes the value of a call by reference parameter, it changes that value in the calling program. So now, do you remember when we said, this was many weeks ago, and I might have even predicted that you would forget this. But do you remember many weeks ago when we were reviewing C++? And we said, you can actually have a variable be a reference variable in exactly the same way that it is a call by reference parameter in a function call. Do you remember that? And how do you do call by reference in a function call? If you say, my function, and then if you say int, and then what do? You say ampersand what? Like I, or something. Okay. And so what does this mean? This means call by reference. And whenever you say I gets 5 here in this function, what happens? The actual parameter in the calling function gets 5, right? Because this is called by reference. It changes it. But then, are you with? Do you remember? You remember this, right? But then, do you remember we said, yeah. That's the way this is like this. But then we said you can actually say int ampersand I. You can say int ampersand I here. And this is called a reference variable. It's like it is here, but it's not. This would not. Let's make this J. This is not a parameter now. It's a reference variable. Okay, so now is where we're going to use these reference variables. You might want to go back and review that material in the C++ review chapter. Okay. So output parameters in the native method are reference variable attributes in the visitor. So now this is going to be an attribute. See, here this is a parameter. Now what we're going to do is we're going to do this as an attribute. And you can do that in C++, fortunately. It makes a really nice connection between these two. Okay. And then, now here's the other thing. Non-void methods, they return something, right? But those accept methods are void. So accept methods don't return anything. Do you see? Here, let's go back. Here's the code for accept. Figure 6.47. What does it say? Accept, what does it say? Void list CSVT. Accept. So accept methods are void. So if the user is going to, if the way the user executes the plugin is to do accept, how can it return anything? So we have to have an additional method provided by the plugin, and we're going to always by convention name it result. And it returns the same type as the type that would have been returned in the original non-visitor method scenario. Does everybody see that? So what's going to happen, the idiom for that, the translation mechanism for that is, what we'll do is we'll have a local variable for what gets returned, and as all we'll do when we do the accept is we'll just set that attribute, not a local variable. We'll have an attribute, and then the visitor will just set that to the value that needs to be returned, and then we will supply a result function for the user to call to get that value. See, that's because accept has to be compiled once and for all in the host program, so we can't anticipate all the different kinds of return results. See, so we need this extra little thing for non-void functions. All right. So with all that in mind, let's do some translations. First thing we're going to translate is empty. So now, the list CS version of isEmpty is non-void because what does it return? IsEmpty returns what? A Boolean. Yeah, it's either true or false, right? Okay. So therefore, the visitor version has to provide a result method, and the result will return type Boolean. So we'll have to set that up. Okay, so to use a visitor for a non-void method, and here again, this follows the same pattern. First of all, you declare a local visitor, and then you pass the visitor as a parameter in the data structure's accept method, And then you call, but then after that, you call the visitor's result method to get the result of the computation. See, so we have this extra little result. So here in the next slide, we have how to do this. So to use the method in list CS, you would say if my list dot is empty, right? Because, and is empty was one of the supplied methods for the list that returned a true or false, and that's how you would check to see if a list is empty. Okay, but now here's how the user would have to do it. Okay, so the user would say LCSV is empty viz, so that's the type, is empty viz, lowercase I. All right, so this is setting up our local. This is instantiating our local visitor. And then what does accept always take as a parameter? Accept always takes a what? A visitor, right? Accept always takes a visitor. And so we do mylist.accept is empty viz. Now what's going to happen is internal to that, the return value is going to be set to either true or false. And so after that, then you would say if is empty viz dot result and call result to get that. You see, so we have this extra little complication there. Does everybody see that flow? Yeah. And
it's set to true or false based on if you're calling the empty case or the non-empty?
Yes, we'll take a look at the code here, and that's exactly what's happened. Okay. That's exactly what happens. Okay, so so result, the precondition for result is that the accept has been executed on the visitor, with the visitor.
Why then do you even need because we have the list CS visitor is list CS visitor is empty visitor.
Yeah, is empty viz.
Attribute called result, which is a Boolean.
Yeah, we'll see.
Why do you even need to have that instead of just return true?
Well, because accept is void. Accept, see, the way you execute, the way you process the code that the plugin developer wrote for you, the way you process that code is to execute accept.
Okay.
But accept had to be precompiled in the host, and we cannot anticipate all the different return types that the user might want. Do you see? So we have to have a way, so the plugin developer has to have a way to get some arbitrary result value back to the user. The reason is because accept is precompiled in the host, okay, and it has to be void, okay, because we can't anticipate all the different possible result types that the user would want. Yeah.
I was going to ask, why can't you just create an accept that returns a type T?
Well, but how do you know T? What type T, type list, type? I mean, int, real, double. I mean, yeah, that's way too. You see, this is more general. Yeah. But these are good questions to think about. These are really good. Okay, so look, here's the code. Here is the code for LCSV is empty. Now look, and on most of these, you guys, I think, in fact, in all of them, I'm going to provide you with the attributes, because the types are, there's a lot of C++ stuff going on here, and the types can get kind of complicated. Right, and so I will, generally as a rule, I'm just going to ask you to do the code, and I'm going to do the attributes for you. All right. But here for this one, so what do we have for the attributes of the visitor? We have bool result, and so that's our output result. And now, and the constructor doesn't have to do anything for the visitor. The constructor for the visitor doesn't have to do anything, because as all it needs access to is the list. It doesn't need access to any other input. All right. So the constructor doesn't do anything. And look, the empty case does underscore result gets true. And the non-empty case does underscore result gets false. And because, see, what it's doing is it's just setting it is just setting its attribute to the correct value, so that here. And then we also have this little auxiliary function called result. And the precondition of result is this visitor has been accepted by a host list, and the postcondition is true is returned if the host list is empty, otherwise false is returned. And as all the result function does is it just does return underscore result. And now, you guys, let's take it one step further. Let's go back here. Why should the user have to know anything about visitors? Why should the user have to do blah, blah, viz is empty viz, my list accept, if is empty viz? Why should the user have to mess with visitors? Why don't we put another level of abstraction and abstract away all that visitor stuff? What is abstraction? Hiding detail. Why don't we just hide the details of the visitor stuff away from the visitor? So here's another thing that we're going to do that's good software design. We're going to provide the visitor, now this is not a method. The visitor is going to provide a global function for the convenience of the user. You see? And this way, this will shield the user from doing this and then calling result and blah, blah, blah. So look at this global function. What does this global function take? Now this is not a method. It's a global function. And look, what does it return? Type what?
Bool.
Type bool. You see? And what does this function, and what does it take as a parameter? A what?
List.
A list. And what does it do? LCSV is empty viz, list.accept is empty viz, and then what? Return is empty viz dot result. So now we can shield all that from the user of the plugin. We can shield all the visitor stuff from the, and so now look, now the user is happy, doesn't have to deal with all that stuff.
You don't even have to do something dot is empty. They're just
Well, now that's an important point. No, yeah, that's a very important point. Notice the difference between how we did it in list CS. In list CS, is empty is a what?
method.
It's a method attached to an object. And my list is an object. And when you say my list dot is empty, the reason you can do that is because in the original system, is empty is a method of a list. But here is empty is not a method of a list. Do you see? It's not a method.
What is it then? Like
It's a function that's not a method of a list.
What is it a function of?
It's a function, it's nothing. You know, before we did object-oriented programming, we just, you can have a function not attached. Do you remember when we started this whole thing in the very beginning of the course? We said all these levels of abstraction. We said you had statement abstraction, structure abstraction.
Structure.
Yeah, we had type. Yes, we had type abstraction,
Structure.
and then structure abstraction, two different types. And that was on the data side. Then we had what? Statement, and then what? Procedure abstraction. Well, that procedure abstraction was just a function, not being a method. Are you with me? Yeah, we've done objects for so long. We forgot that you can have a global function that's not a method.
Interesting.
Yeah, but see here, but see here, the way the user uses it, because it's not a method, you can't say my list dot is empty. You say if is empty my list, and is empty is that global function for convenience. Okay, result is an additional method of the visitor. Okay.
Is empty visitor.
Of the is empty visitor, but it's not one of the ones from the abstract. It's not an implementation of an abstract method. So it is. And furthermore, I'm not sure if this is answering your question, but furthermore, this global function also, notice that it's outside the closed brace. You see, this brace right here is the closed brace of the class. So you see then that this is empty is not a method of the visitor, because we don't want the user to have to deal with visitors.
Right.
If it were a member function, then the user would not be shielded from all this visitor stuff. Yeah.
So if is empty is not in visitors, when we have it like in the global function, how does the plugin implement it if it's not a part of the visitor stuff?
Well, the compiler does. When you include this, the compiler will see that. When you include, it's in the file, it's just not in the class.
okay.
It's in the file. When you include the file, the compiler will see it and will recognize it as a global function.
And the reason that list CSV, like the original one, doesn't need to see is empty is because it doesn't deal with it. The only thing that deals with this is empty is the visitor class.
Well, the user deals with is empty. The user calls is empty.
But wouldn't you have to recompile the whole thing then?
This is a service, this is a global function provided by the plugin developer, so that to make it easier for his customer to use the plugin.
Wouldn't you have to recompile the whole, like...
Just the plugin. This is the plugin. It's part of the plugin. It's not part of the visitor, but it's part of it's a global convenience function that the plugin developer provides for the user. It's true that all that stuff has to be linked so that the user can recognize the isEmpty function, you see. Yeah.
The previous slide and this slide are one file.
Yes, that's a good point. All this figure 6.48, all that's one file. But you see the class stops before this global function.
Yeah. But it's still in the
It's still in the same file. Right. Maybe that clears it up a little bit. Let's trace through and see the calling, see who calls what. All right. So first of all, the user is going to call it, right? So here we are in the environment of the user. Okay. And the user calls mylist.accept isEmptyViz. All right. Now look, when he makes this call, here we are in the environment. When the user makes this call, where is accept? Who is executing accept? The plugin or the host? The host. Accept is up there in the host. Are you with me? So when we make this call, that takes us into where? It takes us from the environment. It takes us from the environment of the user to the environment of the host, right? So that puts us in the environment of the host. All right. Now, when we are in the environment of the host, what happens is, so now we are executing accept, right? All right. But now we saw the code for accept. Look, here's the code for accept. So now here we're doing. Now, what does accept call? What does the list version of accept do? It does what? Head arrow accept star this visitor. Right? So that's the next call that makes. Now where does that put us? What does that put us into? Well, here in the environment of the host. Let's write that down. It calls underscore head arrow accept, and then it does star this, right, and visitor. Now when it makes that call, what's going to happen? Polymorphically, it's going to go to one of these two, right? Let's say it's a non-empty node. Are you with me? So now that's going to put us into the what? Environment of a what? This is the environment of a host, non-empty node. Do you see what's going on here? And then what does this non-empty node do? He calls what? Visitor what? So visitor dot non-empty case owner. Right? Now he's calling what? Visitor.nonempty. Now that puts us into the what environment? Into the visitor. Yes, that puts us into the environment of the visitor. You see, that's this. So does everybody see how that sequence worked? Right? And the thing of it is that this visitor got passed. Where did this visitor come from? That got passed as a parameter. You see? But the visitor itself has an environment. So it's kind of, here, I tried to illustrate this by this sequence of figures. Look. Now, what is the environment? This figure 6.49a shows the environment of visitor isEmptyViz. Now, why, do you see, why do we have an underscore result? Because that code that we just looked at for isEmptyViz, see here? It has an attribute, right? So it has an attribute. So the environment of the visitor is empty. It's kind of like, that's what it is, okay? But then what happens is this. The environment, when after the user calls mylist.accept is empty viz, that takes us into what? Environment of the host. Now what is the host? It is a what? It's a list. Are you with me? It has an underscore head, just like before. So do you see? There's the underscore head of the host, blah, 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 blah. But what else is in the environment there? It's the attributes, underscore host, but what else? The what? The parameter. But what's the parameter? Parameter is a visitor. So it's like the visitor has its own little environment inside of it. The environment is being passed. The visitor, you see what it's kind of, you see? Because the visitor is an object now, and this object has its own little result, you see inside the, are you with me? Right? But then what happens? This one calls what? This one calls the what? The non-empty node. Well, now see, it's the non-empty node of the host, see? So this is like the not, and what happened was that visitor got passed as a parameter, right? Are you with me? And so here it's like, but here's the thing. It has an underscore data and underscore rest, but, it doesn't do anything with that. The accept just calls what? Yeah, question?
So you have access in this environment right now, you have the access to the attribute underscore result.
Well, actually, no.
Because it's in a separate...
No, because, yeah, that's a good point. I put that there. You see, the code in the non-empty node version of accept actually can't get to result.
Okay.
Because it doesn't know what its type is. It doesn't know what, as far as it's concerned, it's an abstract visitor. You see, but underneath it's kind of there. But look what happens. It passes. Now, what does this one do? This one calls what? This one calls what? Visitor.nonemptycase. He uses a visitor. So he calls visitor.nonemptycase, right? So now it's calling visitor. So now we are back to the what? Visitor. We are back to the visitor code, in the visitor's environment, all right? But look, what got passed as a parameter? Owner. Now we are naming that, the formal parameter for that, we are naming it host. All right?
So host and owner are the same thing?
Yes. Host is what we used to call owner. All right? But now look, you guys, here is the environment. Now here comes an important point. Here, what happens is, here we are, and this is the environment that you are in when you write a plugin, when you write the code for a plugin, when you write the code for the empty case and the non-empty case. Because you have been given in every case, when you are writing the code for a plugin, you have access to host is always passed. That was compiled once and for all. Once and for all. So you see, if you need to get the first, you have the host provides us a first. If you need the rest, the host provides us rest. See? So you know what first and rest of the host is, as well as what other attributes you have to work with. So you see that this environment here got augmented by host because host was passed as because owner was passed as a parameter. Yeah.
Is host type list?
Yes. A good question. Host is of type lists.
So host has a head which you can access.
Yeah. Host good question. What does host have? Let's look. See, now this is, in fact, this was your question from yesterday. How does it have access to all that stuff? Look. These methods, copy head first, operator gets, prepend, rem first, rest, and set list. All of those are methods of host.
So
do you see? So that's how, because that was passed as a parameter, that's how the plugin has access to those methods, because this was passed as a parameter. I think I postponed your question yesterday until now. Yeah.
So is what's happening here that host is / has a list and the user is...
The host is a list.
Is a list.
It is a list.
And the user is interested in what is what the list is doing?
Okay, and the plugin developer writes code using that minimally complete set of operations to do whatever processing you want. You could shuffle with those.
So the user is wanting to do things to / access hosts, which is the list. It's not like the user is coming in with their own list that they want to do these things.
Yeah, the user can pass a list as a parameter. The user could pass a list as a parameter, and then or it could just use its own list. Like if you could shuffle one list, you could say mylist.shuffle, or it could pass another list as a parameter. If you wanted to merge two lists, you could say mylist.merge your list. I mean,
So the hosts list is doing what?
It is the user's list.
That's the user's list.
Yeah. It is the user's list.
user's list.
Yeah, yes.
My list.
It's like in Photoshop, it's your image.
So my list becomes.
My list is the host. Becomes the host.
That is its type. Its type is a list CSV. Yeah, that good question. Like my list is of type list CSV.
And then it becomes host.
Well, the plugin accesses it through host.
Okay.
Yeah. Oh, these are good questions. Yeah. So this is a list CSV.
So then what's the point?
Remember, the point of this whole thing is that we can just have a framework, and we can add functionality, we can add methods without recompiling, just by sticking in a plugin. That's the purpose of this whole thing. If you forget that, then all of this just doesn't make sense. You see what I'm saying? That's the point. That's where we started. Are we good? Is everybody? These are all really good questions. Okay, so figure 6.49 shows these environments. I think it helps. You see, and the last one, the point is that the environment consists of the attributes and the parameters. And one of the parameters that you always have to work with is host. You see, are you with me on that?
Mm-hmm. So if we're
Question?
going
Yeah.
to finish, there we wrote environment of visitor, and we
Yeah.
didn't write anything else. Is that because it's done, or?
Well, what I'm saying is this illustrates the environment that you have to work in when you write the empty case and not a non-empty case. When you implement empty case and non-empty case, this is your environment. None of this, all of this stuff is intermediate. Not in your app, you see, not in your class.
So when would the result method be called?
The user would, remember we had the code for when the user recalls.
And that's post, on this diagram.
Well,
after
okay.
that.
Maybe this. In part D, this is the environment that we are in when we said empty case underscore result gets true.
Right.
But that's the environment. In a more complicated one, we might have to, like if we wanted to return something, we might have to access part of the host.
Mm-hmm.
I mean, we might have to access the part of the list, either the first or the rest of the list, but the host provides us with that. Okay. So here are some general translation rules. See, when we looked at those lists of the minimal complete set of operations, two of the most important ones were first and rest. Okay, so in general, the way you translate is, if in the non-visitor list CS method you had to deal with underscore data, now your environment doesn't include underscore data. On the other hand, what you do is you use host.first now where you used underscore data before. So this is a little translation rule.
Returns type T, which is data.
Yes, it returns the underscore data of, if you look at the code, it returns the underscore data of the owner. You see? So we provide it, so we set up those methods so that you can still have access to the underscore first and the underscore data, so that you can have everything you need to do whatever processing you need.
So you don't have access to underscore head.
You don't, not directly, but you do have access to underscore.
You have to call method.
Yes,
Host.
yes, and those methods, and here again, what you have to work with here, you guys, it's right here in this figure. It's those right there in list CSV, okay? That's what you have to work with when you code a visitor. And it's host dot whatever. You see what I'm saying? It's host dot first. You can prepend, you can rem first, you can rest, you can do everything. You can shuffle a list, you can do anything. You can reverse a list, you can do anything with those, just those. That is sufficient. That's a minimally complete set of operations. Okay, now I see what's going to happen. We're going to have time to do the stream visitor, and I'm going to have to screencast the max visitor for you. Okay. So here's the stream visitor. We have two more examples I wanted to go over. We'll do the stream one now. We're going to do a code walkthrough now of LCSV toStream viz. You see, the list CS version of toStream is void, right? The list CS version of toStream is void. Therefore, the visitor version does not provide a result method. The list CS version has an output parameter OS, so that the visitor version has a reference variable attribute underscore OS, because we passed OS to toStream before. All right. So now here's the code for toStream. I think you will recognize we did a code walkthrough of toStream in list CS. I think you'll see how similar it is. So the attribute of the toStream visitor is OS, and it's OS ampersand. Notice that is a call by reference. It's called by reference in the list CS version. Okay, it's a parameter that's called by reference, and so therefore it's a reference parameter in this one. And in the constructor is when is where you do underscore OS gets OS. That's in the initializer list. A picture up here on the upper right part of the figure is the environment, and as always, a visitor has access to host, and this, because that's a parameter. Are you with me? You see, it's you can see here when it says void empty case list CSVT host, and also non-empty CSV host, right? So host is a parameter. You always have access to that. And then cout is part of the environment because it is our attribute. All right? So let's take a look. In the empty case, what do we have to do? We just underscore OS stream what? The open and close paren, right? Otherwise, in the non-empty case, what do? We stream what? To our underscore OS. We stream our open. And now what did we do before? We streamed what?
Open paren data.
Underscore data. But now we don't stream underscore data. We do stream what? Host dot first, because where we did underscore data before, we do host dot first here. You see? And now, do you remember what we did before? Before we had a helper. We had a toStream helper. So now we have a toStream helper visitor. So how do you do a visitor? We have a toStream helper viz. We pass OS, and then remember what we did before? We did underscore rest, blah blah blah. So now this is host.rest.accept toStream helper viz. So, and we are accept a visitor. All right. Does everybody, you see the pattern? All right. And then here's the helper. Here's the helper, the toStream helper visitor. Okay, it's the same constructor to pass the output parameter along. And then for the empty case, what do? We just do OS stream what? The left paren, because if it's empty, then because we do these in pairs, right? We do the comma followed by the data, the comma followed by the data, the comma followed by the data, and then if it's empty, it's all we need is the right paren. Yeah. And then otherwise, and then for the non-empty case, we do what? Stream the comma, and then what? Host dot first, because what did we stream before?
Data. Underscore
data, yeah. Here, so host dot first. And now, you guys, how do we? Now, here's another. Let's see if this is. Here's another thing. What are we in? We are in a helper visitor, right? So tell me, what is this?
Two-stream.
It's always in general, what is this? It's always a pointer to the what? To the current object. So this is a pointer to a what? To a helper visitor, which means star this is a what?
Two-stream.
It is a helper visitor. And that's exactly what accept needs. So we could, have a new local helper visitor and, instantiate a new one, but we might as well just use the same one that we have here. So we just accept star this, host.rest.accept star this. So here's a comparison. So we have code for the non-empty node in list CS. And so before what we did was rest._head arrow two-stream helper, right? But then the code for the non-empty case in list CSV is instead of streaming data, we stream host.first, and then instead of calling the helper, we set up our own local one and we accept. And then here's the code for the non-empty helper in list CS, and here we streamed in the list CS, we streamed the comma followed by underscore data, and then we called rest._head arrow two-stream helper. Here's the code for the helper case for the list CSV. Instead of streaming underscore data, we stream host.first, and when we call the helper, we can just call this same helper by accepting star this. And so this last one here is a visitor optimization technique. You could set this one up. It would still work if you set it up by having a local visitor helper and then doing it with that new local visitor.
That would cost more memory.
That would cost more memory, yeah. Okay. Well, unfortunately, I'm not only going to have to screencast Max, but I will also screencast Clear. And sorry we didn't get through all this material. But anyway, it'll be available for you online. Okay, as we mentioned in the lecture, we're going to conclude this lecture with a screencast. So first, let's take a look at list CSV, the clear visitor. So the first thing to note is that the list CS version of clear is void, and because it's void, we don't need to have a result method for the visitor version. And another issue about clear is that clear modifies the list. And so because you cannot clear a constant list, that means that the constant version has to implement that precondition. So in figure 6.52, we have the code for the clear visitor. And there is the constructor, so notice that the constructor here does nothing because there are no parameters and there's no return value. There's no attributes that need to be set with the parameters. And now, as is the case for the list CS version, if the list is already empty, then there's nothing to clear. And now look how simple this code is for the non-empty case. For the list CS version, the first thing we did was we recursively cleared the underscore rest of the list. So now, instead of doing that directly, the clear is done with a visitor. So in place of that code, we have host.rest, which corresponds to the rest of the non-empty node in the list CS case. And we say .accept star this. Now here again, what is this in general? This is a pointer to the current object. In this case, the current object is a visitor. So this is a pointer to a visitor, to this visitor, and star this is a visitor. And that's precisely what accept takes. And so when accept takes this visitor, it will recursively clear the rest of the list. And after it has cleared the rest of the list, what do we have left? We have a list with just one element in it. And we are, in this non-empty case, we are that first node in the list. So it's all we have to do is tell the host to do .rem first, which is, and remember, rem first is one of those methods in the minimally complete set of methods available to the plugin developer. And so we can just call it host.rem first, and that will delete this this node. What could be simpler? And then here in the remaining part of figure 6.52 is the const version. So this is a case where frequently the const version, it has the same code as the non-const version. But in this case, of course, the const version means that the user is trying to clear a constant list, and because that violates the precondition, this is where we implement the preconditions for that. And before we take a look at the max visitor, I think it might be helpful for us to quickly run through what the max visitor looks like in the list CS version. Okay, so on this slide, from the previous section of this chapter, we have a summary. You remember a summary of the max method, and you remember that max uses a helper. So the list version of max returns a type T, and it has a precondition that the list is not empty, and the postcondition is that the maximum element of this list is returned. But then it used a helper, and once we are in the helper, we stay in the helper. The max helper calls the max helper, you remember, but the max helper takes a parameter, and the postcondition, so the parameter is called val, and the postcondition is that the maximum element of this list and val is returned. So let's review what this code was in the list CS version. So here, the list version, of course, doesn't know whether he's empty or not, so he calls underscore head arrow max. Now, of course, this code in the visitor version is executed by the host, so we never see this. The accept methods in the host actually calls this for us, so we only have to worry about the empty case and the non-empty case. But we see here that in the empty case, that's where we implement our max precondition violated, because the list is empty and an empty list has no maximum. Otherwise, what do? Otherwise, we are in the environment of a non-empty node. Do you remember this? And with this non-empty node, we have access to underscore data and underscore rest. So what we do is we take our underscore data and we pass that to max helper as a parameter, and then we execute underscore rest dot max helper. So underscore rest is the rest of the list. And then on the helper side, what happens is the list version of the helper just forwards on the request to the node version and passes along val, which was given to it by the non-empty node version of the regular of the previous. And then what happens is, if we are in the empty node and we are asking what is the maximum value of val and the empty list, obviously the maximum is val. So all we have to do is return val. And now here in the non-empty node is where the actual comparison takes place. And notice that we use this trinary operator. We're not going to be able to do this in the visitor version because the code is more complex. But basically what we do in this list CS version is we now in our environment we have two values. We have val that was passed along as a parameter, and we have underscore data, which is our attribute of this non-empty node. And we check if data is greater than val, what do? If data is greater than val, we know that what we should return is the maximum of data and the rest of the list. Otherwise, we want to return the maximum of val and the rest of the list. And the way we do that is by recursively calling the helper again. So in each case, it's rest.maxHelper. In one case, it's rest.maxHelper with data. In the other case, it's rest.maxHelper of val. So that's a review of how the max method works in the list CS. Now let's go back to our visitor now and see how that translates. Because remember, all we need to do is be able to translate from the list CS version to the list CSV version. So now let's take a look at the LCSV max visitor. So the first thing to note is that the list CS version of max returns type T. because it returns type T, that means that our visitor version has to have an extra attribute called underscore result of type T. And what about the max helper viz? Now the max helper viz not only returns a type T, but it also has that little extra parameter. So the list CS version of max helper returns type T and has a parameter val. That means that we're going to have two attributes in the visitor version of the helper. So the visitor version has attribute underscore rest of type T because for the non-val characteristic, and also an underscore val of type T for the that corresponds to the parameter. So here's the code for the max visitor. In figure 6.53, first of all, for the max visitor, notice that we have this attribute const T star result. So result is a pointer to a type T, and that's going to be returned. That's going to be used to send back to the main program the return value. The constructor doesn't have to initialize anything because no parameters are being passed to the higher level max viz. And as we had before, in the empty case, the main program is asking if for the maximum of a list that is empty, and an empty list has no maximum, and so we implement the precondition as usual there. And then in the non-empty case, you recall, what we had to do is we used our underscore data as a parameter and called the helper. But in this case, you see, the helper is itself a visitor. So what do? We set up our little local, we instantiate a little local max helper viz, and we pass along, whereas before we passed along underscore data, now what do we pass along? Host.first, so that's according to that recipe that we saw a minute ago. And then we call host.rest.accept max helper viz. So accept takes max helper viz as a parameter, and previously we called the underscore rest version the underscore rest of the helper. So this time we access that by saying host.rest. And then because this is a method that returns a value, then what we do with that, is we set our underscore result to max helper viz.result. And then when the main program wants that result, or when the convenience function wants that result, what it does is it calls the result function, and result just returns star result. So because result was a pointer, we return what it points to. And now, what about the max helper viz? What about the max helper visitor? Now you remember there were two things about this. First of all, it had an input parameter, and second of all, it returned a result. So corresponding to these two items, we have an underscore val, which corresponds to the parameter, and the underscore result, which corresponds to the result. And this time, our constructor requires us to initialize underscore val to val, which it gets from the parameter list, because that corresponds to a parameter. And then in the empty case, and so you remember that we had to return val in that case, but in this case we set our attribute underscore result to underscore val. And then in the next part of the slide, this is the part that had the trinary operator, and you remember our trinary operator compared underscore data with val. So here what we are comparing is host.first, which corresponds to the old underscore data. We say if host.first is greater than val, then what do? We have to call the max helper. But the max helper is a visitor. And in this situation, we cannot use that optimization technique because we have a local variable. We have a local attribute. And so that requires us to use the full-fledged three-step process to call a helper. So we have to allocate our max helper viz anew and give it host.first, and then go ahead and call host.rest.accept max helper viz, and then underscore result gets max helper viz.result. So this is the, and similarly for the else part, except that what we are passing along as the parameter, or what we are passing along as the parameter is underscore val instead of host.first. So these patterns all follow the recipe that the translation recipe that we laid out before. And then in figure 6.55, we have our usual result function that returns underscore result and the global function for convenience so that the user can be shielded from all of this visitor stuff. So the next few slides show the comparison of the original listcs code with the code for the visitor version. So the code for the non-empty node in listcs is return underscore rest dot max helper underscore data. Now, of course, what corresponds to underscore data is host.first, so that's what gets passed. So that's what gets passed to the constructor when we set up our local helper viz, max helper viz. And then because we return underscore rest.max helper in the listcs version, the thing that corresponds to that is host.rest.accept max helper viz. And then because this is a non-void method, we set underscore result to, we call the result function of the max helper viz and set underscore result to that. And then finally, we have the code for the non-empty helper node in listcs. Now, I've shown you in this slide, we're just comparing the second, in the trinary operator that we had in the original listcs, we tested underscore data in val. Here, and then what we did is the code for rest.maxHelper passing along val is shown here in the code for the non-empty helper case in listcsv. And you can see what corresponded to val before corresponds to underscore val here. And what corresponded to underscore rest corresponds to host.rest here. And then we have this usual pattern with underscore result gets max helper viz dot result, which is the call to the max helper result function, result method. And so one parting observation about all of this, you will find that if you try to just follow the recipe and pay attention to the types, and if you can get it compiled, I almost guarantee you that it will work. Because if you're anywhere close to following the recipe, the hardest thing to do with these translations is to pay careful attention to the types, the point, whether it's point or whether it's dot or whether it's arrow, whether it's ampersand, whether it's star. But once you work that all out, if you can follow this pattern and get it to compile, chances are 99.9% that it will work. So anyway, good luck and happy coding.